Greetings. In this first video, we will talk about a type of motion we haven't talked about yet. And I'm going to introduce it with this question to pose to you. Can an object moving with a constant speed experience an acceleration? If this were in class, I'd have you use the clickers and perhaps discuss it with one another. But since it isn't, I'm going to have you pause for just a second, think about it, and write your answer down, and perhaps why your answer is what it is. And I'll come back in a second. Okay, I'm back. Don't know what you thought, but I will give you a demonstration as to why the answer actually is yes. An object with a constant speed can experience an acceleration. If an object has a constant velocity, it cannot. It would have a zero acceleration in that case. However, in this case, if an object has a constant speed, its velocity could be changing. So it could have a non-zero acceleration. And I'm going to give you an example of that right now. I'm going to twirl this over my head. This is a little connector. Okay, so when I twirl that over my head, it's a little hard to do here. I can do it like this too. When I twirl that, you see it's constantly having to change direction. And every time it changes direction, its velocity is changing. So its velocity is constantly changing, so it is accelerating. And that is what we'll be talking about. This is called circular motion. So any object that's moving in a circle, such as this one, some force has to be causing it to move in a circular path. In this case, that force is this string. It's actually a little thread. This thread is causing the object to stay in this circular path that it's following right here. And basically, I'm constantly pulling on the object to keep it in that circular path. And you see me pulling on it because my hand's moving up and down. That's what's actually going on. This is a tough thing to use. I should use a piece of bigger string, but in any case, this is what I got. So any object moving in a circular path has to have some force. In this case, that force is a tension force. However, there's other cases where the force could be something different. It could be friction, could be a normal force, could be gravity. So there's a number of, any force could act as that force that causes an object that's moving in a circular path to stay in that circular path. And whatever that force is, whether it's tension, friction, normal force, or gravity, that force is called the centripetal force. And that's what the next slide here shows. And when the object is moving in the circular path, the acceleration that results from that, there is an acceleration here. I'll talk about that in a couple minutes. It's called a centripetal acceleration. Anything centripetal means it's wanting to go towards the center. In other words, without me pulling on the string, this object would fly off like that. But because I'm pulling on the string, the object is accelerating towards the center. See, there's a force pulling on it towards the center as well. There's a net force and an acceleration, both towards the center. And Newton's law would predict that. So here's a few examples of objects that experience circular motion. Twirling an object with a string, which is this. Car driving on a circular track. Or whenever you're taking a turn, you might experience this. You've noticed sometimes you might go into a skid. You're more likely to go into a skid when you're trying to take a turn than if you're driving on a straight path. Objects in orbit, for instance, the moon orbiting around the Earth. And many of you have also experienced amusement park rides like roller coasters. That's another example of circular motion. So I want to think about the acceleration that this object experiences and what might affect that acceleration. Now, if the last thing was hard to do, this is going to be even harder. Let's say I twisted this. What can change? What about this motion can change? There's a few things. One is I could change the length of the string around which this object is circling. I could also change the speed. I can either go fast like this, or I can go slowly like this. I can go more slowly like that. That's going to affect the acceleration. So will the length of the string. When it's really small like that, it's really hard to do this. It has to change the direction all the time. So these are a couple of things that affect the acceleration. We have the length of the string, and we have the speed of the object going around here. And the other thing that could affect the force is how heavy the object is. If this object were lighter, I wouldn't have to use as much force to make it go around in a circle. So the mass of this object also affects what's called the centripetal force, so the force required to keep the object moving in the circle. If it's a nice small little object, it'd be much easier than this awkward kind of heavy thing. So the factors that would affect it are the length of the string, the speed of the object, and those are the only two that I can imagine affecting the acceleration of an object on the end of a string. So given that, the speed of the object and the length of the object, I'm going to end this short little video here, this introduction, by asking you, can you come up with an equation that only includes the speed of the object going around the string and the length of the string, or the length of this thread? Can you come up with an expression that will give you units of meters per second squared? This is called dimensional analysis. And using dimensional analysis, we can come up with an equation that will describe a quantity we're interested in finding. So if we can come up with something that describes the motion in meters per second squared, then we actually have the equation for our centripetal acceleration. I'll end this video and ask you to consider that.